Hello and welcome to one more session about Layerix University. I am Swaminathan. I am the Managing Director, Founder and Chief Technology Officer. In this world, there are only three types of network traffic. Number one is unicast traffic. Number two is broadcast traffic. Number three is multicast traffic. Unicast traffic, let us first write down the various components of a packet. So if this is the packet, there is data here, and then there is a source IP, there is a destination IP, and there is a source MAC, and there is a destination. So for destination IP and source IP, we are going to use the unicast IP addresses. As an example, it can be 10.1.1, 20.1.1. If you consider a switch like this, unicast traffic is used for traffic flowing between two endpoints. It's a one-to-one from here to. For broadcast, if you want a traffic to pass to all the ports within the same VLAN like this, you can use a broadcast state wherein the traffic enters like this and it is given to all the ports within the same VLAN. What if we want to send traffic to only two interfaces? For example, the traffic has to come like this and only go to these two and not to these two. This is where the concept of multicast traffic comes in. Multicast is given by, so broadcast, the source IP address is any unicast IP address, for example this. The broadcast IP address is always 255.255.255.255. This is the broadcast. For multicast, the source address is still some unicast IP address. The multicast address can be anywhere between 224.0.0 to 239.255.255. This is the multicast IP address. This is the broadcast IP address, and this range is called the multicast IP address. Now imagine a traffic which is flowing from here with a unicast IP address of 10.1.1.1 and the multicast IP address is 225.1.1. The traffic comes here. However, because they are all in the same VLAN, the multicast traffic is handled like a broadcast traffic, which means each of these ports will be getting the traffic. That is a problem. That is why there exists a protocol called IGMP. In IGMP, only the ports that are interested to receive the traffic will send a join message, and then the traffic will be passed on to that port. For example, in this case, only this and this will send a join message, and the multicast traffic will start flowing from here and then there will be no traffic on this, there will be no traffic on this because they have not sent the join message. IGMP is only for IPv4. IPv6 uses another mechanism called MLD. Whereas the source MAC address and destination MAC address for unicast, we all know. But remember one more point, that a multicast IP address can never be a source. It can only be a destination. Always the source is represented as a unicast IP address. The destination MAC of a multicast IP address will begin with 0, 1, and then anything XX, 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 XX. The starting 8 bits will always be 0, 1. The remaining 40 bits can be anywhere. Then what is the concept of IGMP snooping? IGMP snooping is an optimization technique. IGMP snooping is an optimization technique wherein the switch can snoop on the packets IGMP joins and then locally take a decision instead of sending it back to the source. So for example, if assume there is another switch here, there is another switch here, and there is a receiver over here who has sent a join message. Because they have sent a join message, the join message comes here, It is then snooped here, and automatically this guy sends a copy of a traffic to below. The role of querier is also very, very important in IGMP. The role of querier is to periodically check if any members or any receivers in the network still wants the multicast traffic. So in a complete VLAN, one of the router or one of the switches appointed as a querier, his job is to send periodic queries over the VLAN to check if there are any interested receivers. So for example, let us now assume there are 2 receivers here. He also sent a join. Now the traffic is flowing to this guy also, traffic is flowing to this guy also. Now, if one of the receiver sends a leave message that I don't want this multicast traffic, then there will be a query for that particular group, which is 225.111. Are any more receivers interested to join this? Then he will say, I am there. Although he doesn't want, but I am there. I still need this traffic. So this tree will not be broken. The traffic will still continue to flow here. So let us say this person also leaves. Again, a query will be sent with a querier. Are any more people interested for this group? Then he will say nobody is interested. Then this is cut. In the multicast forwarding entry, this will be removed. That concludes our session on multicast IGMP IGMP snooping. We are Layerix networking experts. With small video sessions like this, we help you make the right choice on your design and technology for your upcoming project. Thank you very much. See you again in the next session. This is Swami signing off.